C program of binary search method that uses non-recursive and recursive functions to search for a key value from the given list. In this, okay, you see here, this is the binary search. Binary means means two parts. We divide the list into two parts to search a particular element. That particular element is called key element. Okay, so for this, first I will explain the procedure. You see here, this is the binary search. Binary means we divide this list into two parts. Okay, search means find a particular element. That particular element is key element. Okay, here my key element is 17. Okay, we have to check either this 17 is there in this list or not. This is the L of array. L of 0, L of 1, L of 2. L of 0 is 2, L of 1 is 5, like that. Here I have given 10 elements. Okay, this all the elements are in ascending order. Okay, you can give in any order, no problem. Okay, you see here, I am going to find this 17. Okay, either that 17 is there in this list or not. First, 0 is the low, index 0 is low, index 9 is the high. Okay, middle is equal to 0 plus index of 0 plus 9 by 2. Okay, 4. We have to take integer. We cannot take 4.5, integer value of 4. Okay, this 4 is the middle. Okay, so my 17, my key element is 17. I have to search either that element is there in this list or not. Okay, that key element 17 is there, right side to this middle, right side to the middle. So this element is key element right side to the middle. That's why from here, this is the unwanted portion, from here to up to middle. Okay, left to left side, from the left to the position of middle, unwanted portion. Now we don't want these elements. Why? Because my key element is right side to the middle position. So now I take, this is the low position. What's my low? Low is equal to middle plus 1. Okay, you see here, next I will take okay, you see here, my low is middle plus 1. My low is, this is my low. Why? Because this is the unwanted portion up to middle, beginning to left to up to middle, unwanted. So this is the low. Low is middle plus 1. Low is middle plus 1, 5. Okay, now low is 5, high is 9. Okay, what's my middle value? Low plus high by 2. 5 plus 9 by 2 is 14 by 2 is 7. So 7 is the middle. Okay, now I have to check either 17 is left or right to the middle. Okay, my key element 17 is there, left side to the middle. Okay, left side to the middle. So this from middle, okay, here this is unwanted portion. Okay, from right to up to middle, this is unwanted portion. We don't want this part. Why? Because my key element is left to the middle. Okay, so what's my high? I have to take high from here to here. This is unwanted portion. This is unwanted portion. So middle minus 1 is the high. Okay, you see here, middle minus 1. Middle minus 1 is high, 6. Now low plus 6. Low plus high by 2. 5 plus 6 by 2 is 5 is the middle value. Okay, this index 5 is the middle value. Okay, now my key element is right to the middle. So right to the middle. So this is the unwanted portion. This is the unwanted portion up to middle. So my low is, this is unwanted portion, my low is middle plus 1, so this is the middle, this is the low, low is middle plus 1, okay. So low is middle plus 1, so this is the low, low is 6, already high is 6, okay. Low high, low plus high by 2, 6 plus 6 by 2, 6 is the middle, this is the middle, okay. Here middle and key value is equal, then we find key element is, we found the key element, okay. And one more condition, till our mid should equal to the key element we have to do. Second condition, this high will not exceed the low position, high will not go after the low, high should not be after the low, okay. Low and high, whenever these two are same position we have to stop, but high will not exceed the low position, okay. Why? Because high will be right side to the low only, na? If we take high right side to the low, then we can't find, okay. At this place we have to stop. Now we found whenever middle equal to key element, yes, we found the key element, okay. Like that we have to search in the binary search, okay. You see here, once again I will explain. This is the list of L of array, okay. I want to find key element 17, this is the low, this is the high, low plus high by 2, 4, this is the L is the middle, middle is 4, okay. My key element is 17, I have to search this key 17 key element in this list, either 17 is there or not, okay. My 17 is there right side to the middle, so from up to middle, from left to up to middle, this is unwanted portion, so my low I have to take from here to here, okay. My low is middle plus 1, so this is the low. You see here 5 is the low, low plus I by 2, 5 plus 9 by 2, 14 by 2 is 7, 7 is the middle, okay. My key element 17 is there left side to the middle, so this is the unwanted portion. I have to take high to here, my high is middle minus 1, okay. Now this is the high, okay. Low plus high by 2, 5 plus 6 by 2, 5, 5 is the middle, okay. My key element is there right side, my key element is there right side to the middle, so this is the unwanted portion. From here to up to middle, unwanted portion I have to take from low here to right side, my low is middle plus 1, okay. Now low index, okay, low will come to here, low is 6, high is 6, low plus high by 2, then we will find the middle element, middle is 6, okay. Here middle is pointing to the index 6, okay. Our key element is there, L of middle, L of 6 is 17, but position is index 6, position is 7. Why? Because 1, 2, 3, 4, 5, 6, 7. Index will begin from 0. Position will begin from 1. Starting is the 1, position 1. We cannot tell position 0, na? So these are the index values. From 0 to 9 are the indices. Indices is the plural for the index, okay. Position is 1. Start from 1, okay. Like that we found, like that we find, till we have to do the process till middle should be equal to the key element and high should not be exceeded to the low, okay. You see here, about to the main, I used prototype or signature of functions to instruct to the compiler regarding usage of type, function name, arguments of the type and arguments, okay. Either you write int comma int comma int, no problem, or you can give arguments also, okay. What are there in the called function, that arguments we have to write here in prototype or signature, okay. For the purpose of compiler, to instruct to compiler, we write these prototype of functions. Unless we use, we will get compiler error, okay. Actual execution will begin from main, okay. Void means it's a data type, doesn't return any value. here maxlen. Okay, here this is the macro definition. Okay, here macro definition is used with the preprocess directive. Okay, behind this preprocess one software will be there. Before we pass our program to the compiler, here it is already processed. Okay, so here it's a macro definition where we write maxlen, at that place 10 will be replaced. Okay, here L of maxlen, that means 10. L of 10, we can give maximum 10 elements. Okay, more than that it's not possible. If you write here 20, you can give maximum 20. Okay, n number of elements. L is the key element. Choice 1 for recursion, 2 for non-recursion. Here POS is -1, here it acts as flag. Okay, next, if choice 1 for recursion, 1 for recursion, 2 for non-recursion, enter your choice. Okay, which one you want to give, either 1 for recursion or 2 for non-recursion. If I give choice 1, my choice is 1, then 1 less than or equal to 2, yes, true. 1 greater than 0, true, true and true, true. Then we will enter into if condition. Okay, how many elements do you want to enter? Next, we read the number of elements, 10 elements. I have shown in example 10 elements. For reading the elements, we use a function. Okay, function is a subprogram. Every function will perform a specific task. Advantage of function, reusability of the code. Okay, whenever we call this function, control will go to called function for reading the elements. Directly we can write here also, no problem. Here also directly we can write for reading of the values through keyboard by using scanf, but here I am using functions concept. Okay, we will enter here called function. We cannot keep at the end of here semicolon. If we give, control will not enter. Lock, beginning of the function, int I, declaration of a variable, enter the elements. We read through keyboard. We read the elements through keyboard one by one. This loop will be iterated 10 times. 0 less than 10, 0 to 0, L of 0, L of 1, L of 2, L of 3, like that, L of 9, that means 10 elements. We read all the elements. After reading, we will go back to the main function. Okay, then we will go back to the main function after reading. Okay, after reading we print the elements. After reading, after the read list, we will come to here print list. Then we call the function. Then we go to called function for printing. Okay, there also in main function we can directly print, we can read, but here I am showing with function. Okay, now I am going to print. Here is the list of array. N is the number of elements. Declaration of I. Elements in list I am going to display. I is 0, L of 0, L of 1, L of 2, L of 3, up to L of 9. All elements we display on the screen. After that we close this. Okay, then we come back. Okay, then we come back to our main function. After the print list, what's there in the main function, that will be executed. After the print list, what's there, it's over. Okay, control will come back to here. Okay, control will come back to here. Okay, enter search element. We give the 17 for our list. Okay, here 10 elements. Okay, search element is 17. EL is the key element. After reading the key element, we will enter into switch. If I give choice 1, okay, here you see here choice 1. If I give choice 1, we will enter into switch concern case. My choice is 1, case 1 will be considered and executed. Okay, here recursion method, we call a function of search recursive. Here you see here, this is the call function. Okay, this is the call function. Okay, this is the call function. L is the list of array, 0 is the beginning of the index, n minus 1, 10 minus 1 is 9, last index, L is the key element. We will go to called function. From call function, okay, you see here, it is the call function. We will go to called function, then we return a value. That return value, when we enter into called function, that will return a value. That value will be assigned to POS. If POS is 1, minus 1, element is not found. Like that we display. Now you see here, now we are in call function. Now we call the function, that is bsearch recursive. Okay, this is the array beginning index, ending index, key element. Okay, we go to called function. Now we are in recursion, binary search using recursion method. Okay, recursive procedure, recursion method. You see here, it's returning integer value. You see here, this is array beginning index, ending index, element. These are the formal parameters. What we give there, that values will be received to this function. Okay, what I have given here, you see here, L 0 n minus 1 element. 0 is the beginning position, n minus 1 is the ending position. You see here that L 0 array start index, ending index, n minus 1, key element. Middle, if array start should be less than array end, that means 0 less than or equal to 9, 0 less than or equal to 9, then only we enter here. Okay, unless we will come out. Middle is beginning plus end by 2. If L of middle is equal to, here binary search recursive, L of middle, what's the L of middle? Here 4. Is L of 4 equal to 17? Is L of 4 equal to element? No. Come to else. Okay, for this if, this else. Okay, next for this if, this else. Okay, now you come to here my element, my key element is less than L of middle. Is my key element left side to the middle? Is my key element left to the middle? No. So we will go to else. We will go to else. Return B of search. Here in the recursion process, whenever we call, we push the values. Whenever we return, the values will be taken out from the stack. That is the popping. Okay, in the stack. Okay, last in first out. Last what we enter the values, that will be taken out. Okay, stack will work on FIFO concept, first in first out. Call a function. When we call a function, push the value into stack. When we return the value, take out from the stack, return the value. Okay, now we come to here. Okay, once again this function is called by itself. Okay, this function is called, you see here, this is the function. Now once again we are calling, and we will come back to our function. This is the recursion. You see here, from here we called once again. Okay, in recursion will not be implemented for all the methods, for all the programs. Only it will be implemented for a few programs. Okay, and we have to check the condition, either we are exceeding the condition or not. If we exceed the condition, then the program will run out of the memory. So some disadvantages are there and advantages are also there in this. Okay, advantage, once you write, you can reuse the code, and the same function will be called by itself many times. It will be repeated to call by itself, to call the same function name. Okay, next, once again process my array start, either array start less than or equal to array end. You see here, what's that? Either 5 less than or equal to 9, yes, then array start plus array end, 5 plus 9 by 2. Okay, 5 plus 9 by 2, 7 is the middle. Okay, L of 7 is equal to element L of 7 is equal to key element 23 is equal to 17. No. Then else if either my key element left side to the middle, yes, so then we call this function, my key element is left side to the middle. Okay, my key element is left to this middle. So what we have to do? We have to take the high is middle minus 1. You see here, high, this is the low position. Array start is this one 5. My middle high is middle minus 1. So this is middle minus 1. Why? Because my key element is left to the middle. So middle has to take to the left side. High position we have to decrease, middle minus 1. Then once again we call this function. Once again it's called by same function. Okay, then now we got middle. What's the middle value? 7. Okay, next, array start less than or equal to array end. Same procedure what I explained here, till we find one by one. Here we will go like this, low and high. Here once again we take here. Okay, low should be less to the high. Okay, middle value we find. Okay, key element is there, right side or left side to the middle. According to that we do this. Okay, if key element is left to the middle, we use this recursive function. If key element is right side to the function, okay, if key element is left to the middle, then we use this function. If key element is right side, then we use this function. Okay, like that the process will, if that function will be called, okay, till we get the solution, till we get L of middle is equal to element. At the time we return the middle value. What's here at the end? Middle value. You see here, my middle value is 6. Okay, if L of 6 is equal to 6, L of middle, what is L of middle? 6. L of 6 is equal to 17. Is 17 equal to 17? Yes. Return middle. What we have to return? What's the middle? This index value 6. Okay, we return that value. Okay, 6 we return, that is the index 6. Okay, middle is the 6, we return middle. Okay, then we will go back. Okay, for example, if that key element is not there, we won't find anything. For example, if we find that middle element as key element, then we return that is the integer type. You see here, it's a returning integer type. Okay, next we will go back to our main function with the return value. This is the body of the function, this is the body. Okay, for recursive function, you see here, For the recursive function, this is the head of the function. Okay, that value will be returned to this function. This is the head, that called function is the body. That return value, okay, 17 will come into here in this call function. That value will be assigned to position. Okay, next, if position, what is the position? 17. Is 17 minus 1? No. Else element percentage d is found at position. What's the ELE? Key element. Okay, here my key element 17 is found at position plus 1 at that. Okay, you see here position plus 1 ELE here element is you see here position plus 1. Here what's that index? You see here 7th position, my index. Okay, you see here this is the procedure for recursion. Next, choice is 1 recursion. If I give choice 2, okay, same procedure, choice 2, that 2 will be, you see here case 2 will be executed, non-recursion. Here we call this, you see here this non-recursion. In this we use loops concept. Okay, you see here we will go to here loops, non-recursion. Non-recursion, same procedure, start array index starting position should be less than or equal to end. Up to that we have to do the process. Okay, left and right, left low position, low should be less than or equal to high, or low and high should be equal. Okay, we find middle is L of middle is equal to element. First time what we will get, you see here in non-recursion we will check as is L of middle is equal to key element. Is L of middle equal to key element? No. Then we will go to else. Okay, if the key element is the right side, okay, if the key element is right side, okay, L of middle is less than element, that means key element is the right side. You see here key element is the right side to the middle. So what we have to do, we have to increase, okay, my low, that means start is middle plus 1. You see here to the middle key element is right side. So this is the unwanted portion. I have to take low to here. My low is middle plus 1. You see here my low, that means start is middle plus 1. Unless if the key element is left side, what we have to do, left side, if the key element is left side, we have to take the high to the left side. High is middle minus 1. Okay, this case will be executed at the time. Okay, till this while loop will be iterated till start should be less than or equal to end. That means low and high, either low should be less or equal to high. That means start should be less than end, or start should be equal to end. Okay, till that, okay, till reaches low position to the high. Okay, we have to do the process, then we have to stop. If low and high will come to same place, for that purpose here I have used while loop. Okay, you see here this is the non-recursion procedure. In this non-recursion we use loops. Okay, for example, if I want to find the element, okay, I reached, okay, from left to right, okay, low and high both are came to equal position, but I didn't find, for example, in this 100 element 100 not there, so low and high will reach, okay, but we cannot find the key element. If 100 is the key element, at that case, okay, here it's over, while loop will be false. If I give 100, both will reach to the same position here, but we won't find 100 element. Okay, so we will come out from this, it will check the while loop, but it is reached start and end equal, so but we didn't find here. So this, what's my flag here? I have given flag is 0. In this flag is 0. Okay, my flag is 0 at the beginning. Okay, you can take any variable. Here I have taken flag. Okay, what's the flag? Flag is 0. 0 equal to 0. Yes, element percentage D. What's that element? Key element. Element 70 100 is not present in list. Okay, this is the non-recursion. Okay, in this recursion we used another arguments. These are the formal parameters. Okay, in call function we use actual arguments or actual parameters. In called function we use formal parameters or formal arguments or dummy parameters. What we call, what we pass the values into call function, that values will be copied into the called function. That is the call by value or pass by value. Okay, you see here what I have given. Okay, what I have given in called function, we have to give same values in the prototype of a function. Okay, in called function what I used, the arguments same we have to write here also, but we cannot write in call function arguments. Sometimes we will have same arguments, sometimes we will use dummy arguments, another arguments in the place of original arguments. Okay, so this is the recursion and non-recursion procedure or functions for the binary search. Okay, while we are splitting the list, we search a key element in the given list. Okay, thank you friends. If you like it, please share and subscribe. You see here one more is there, that is for example, if I find the element at this position, we have to write 6 plus 1 7. For example, if I find here this is the 7th position, this is the 0 index, position is 1. Okay, now I will compile and execute this program. Enter your choice 1. How many elements do you want to enter? Okay, here I will give 10 elements, 1 2 3. Enter your choice 1. How many? Here I have given one element only, 2. Search element is 3. Element 3, sorry, you see here enter your choice 1. Choice 1 recursion. Recursion will not be implemented for all programs. Okay, it's limited, but whereas in non-recursion it will be implemented. Non-recursive procedure can be implemented for all programs, but recursion only for a few programs. Okay, according to our requirement we take the recursion. Okay, next, how many elements? For example, if I give 4 elements, okay, 2 6 7 9. Okay, I have entered 4 elements in list are 2 6 7 9. If I give 7, in my list 2 6 7 9 are there. 7 element 7 is found at 3rd position. Okay, you see here first one is the binary search, choice 2 is non-recursion, your choice is 1. How many elements you want to enter? 4. My elements in the list are, these are 2 6 7 9. Search element is, key element is 7. That 7 is found at 3rd position. Okay, You see here that 7 is at third position. Okay, you see here in this 7 is at third position. Okay, you see here if I give choice 2, once again I will execute, compile and run. I will give here choice, enter your choice 2. How many elements? If I give 5 elements, okay, 1 2 3 4 8. Here I want to search 8. Search element is 8. You see here element 8 is present at position 5. You see here 1 is for binary recursion, 2 for non-recursion choice. 2 choices are there. If I give choice 2, that is the non-recursion. How many elements do you want to enter? 5 elements. I entered 5 elements. In the list, what are there? 5 elements. 1 2 3 4 8. I am going to search the 8. Key element is 8. Search element is 8. Either that 8 is there or not, I will check. This is the non-recursion method. Element 8 is present at position 5. You see here 8 is at 5th position. Okay, index 4, but position is 5. Okay, index plus 1 is the position. Thank you friends. If you like it, please share and subscribe.